Hello and welcome to another presentation, this time on binomial expansions at A2. Now the difference between AS and A2 binomial expansions is quite simply that they start asking them to do expansions where the power is not a positive whole number. When the power is a positive whole number, you can rely on just Pascal's triangle or the binomial coefficients in Pascal's triangle, and you don't really need much else. But if you want to take n as a fractional or negative power, then suddenly we end up with this infinite expansion. Now, this infinite expansion really, I think the easiest way to prove it is probably using a Taylor expansion, Maclaurin's expansions. The answer drops out really nicely then, but they don't actually do that till FP2 or FP3, depending on which exam board you're studying. So it's one of those curious situations, and it's always bothers me a bit when I have to teach it like this, where you have to kind of say just accept this as a true statement. Maybe some other teachers much better than me have a better way of demonstrating that it's certainly the case, but a rigorous proof of it seems to me pretty difficult to give when they haven't done the required level of maths to prove it. But it's a very easy formula to use, to be honest. Now, one of the first things I always point out is that we're still using Pascal's triangle because we're still using binomial coefficients. N choose 0 is 1. N choose 1 is n. N choose 2, as I proved at the end of the last video, is n times n minus 1 over 2. N choose 3 is n minus 1 n minus 2 over 3 factorial, and so on and so forth. So we are still using Pascal's, binomial coefficients. Now the other thing which you really should point out is this is not true for all values. It's only valid if x is small. And that's another reason why you might want to show the proof with something like Maclaurin's expansion, where it only is true around x equals 0. Well, this is certainly only true when x is small, when x is trapped between 1 and minus 1. And the smaller x is, the more close the expansion is for just taking the first few terms. Now, this isn't going to be a long video. I'm just going to literally very quickly show you how we might use this to find an approximation. Now, let me quickly write up for you a typical A2 question. Okay, this one isn't a tricky one. It just says expand 1 minus 2x to the half, finding the first 3 terms. Now, the reason why I immediately know it's not too tricky is because of that 1 there. It's very important that this formula only works for 1 plus x to the n. The x actually can be x squared minus 3x, 2x cubed. You just replace all instances of x with whatever is sitting there as the variable. But you cannot have a 2 here or a 3 here without having to do some fiddling around. Now the presentation, the PowerPoint presentation, shows you an example of that. As soon as you've got a 2 here, you'll need to divide through by 2, but don't forget to put it to whatever power you've raised it to, and then apply it at the end. It just makes it slightly more of a fiddle if there's not a 1 there. Fortunately, we're not in that situation, so we can get straight down to writing down the answer. 1 minus 2x to the half is 1 plus n times by x, and I always get students to put it in brackets because it's one of those questions where it's easy to make a mistake, plus n times n minus 1, no need to rush in other words, times by x squared over 2 factorial. Now I'm just going to put dot 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 after that because it's not exactly equal. We only need the first 3 terms though. That gives me 1 minus x, and then the next value is also going to be negative, and I'm going to get minus quarter divided by 2, which is minus an eighth. Oh, but I've got minus 2 squared, which is 4x squared, so it's going to be minus x squared over 2. And those are the first 3 terms. Now what the question may finish with is asking you to do an estimation. Hence estimate the square root of 0.98. Well, if we replace x as 0.01, we will immediately find an estimation for a square root of 0.98. So all I've got to do now is plug that into my formula, just using the first 3 terms. 1 minus 0.01 minus 0.01 squared divided by 2. And then I can find the value of that, And the whole point of this, by the way, this was often used in the good old days when there were no calculators, when you could easily establish what this equaled and therefore find a pretty good estimate for the square root of 0.98. And that equals 0.98995. Now, because this was very, very close to 0, that is actually an extraordinarily close approximation. I've just worked out on my calculator the actual value of 0.98, square rooted, and it's 0.989949. That's how close we get with these binomial expansions, provided x is very close to 0. The closer to 0 x is, the better the approximation will be, just using the first 2 or 3 terms. And that's a remarkable thing, I think. It's an incredible way of approximating value. Okay, I hope that makes sense. Now bear in mind that at A2, what they'll often do is get you to use maybe some partial fractions, or maybe a little bit of fiddling around at the end with the approximation. There's a couple of ways they can make the question a slight bit more difficult, but I hope this puts you in the picture for what a kind of typical question looks like at A2. Thank you very much for listening, and good luck with the rest of the course.